In this lesson, we are going to learn about equivalent ratios. Two ratios are equivalent if they show the same relationship. Here's an example of two equivalent ratios. The beauty of equivalent ratios is that we can find patterns in all directions, always using multiplication or division. There are three key multiplicative patterns that will always be present if two ratios are equivalent. The first is across the ratios. In the example provided, if we look across the two ratios, we see that the first ratio is 2 times the second ratio. The second pattern is within the ratios. If we look within each ratio, we can see that in each one, the second number is 3 times the first number. The last pattern is that cross products will always be equal if the ratios are equivalent. To see this, we must first rewrite our ratios as fractions. You get cross products by multiplying across the diagonals of this equation, the numerator of one ratio times the denominator of the other. In other words, 4 times 6 and 12 times 2. Since both of these products are 24, we know our ratios are equivalent. This pattern doesn't give me the most insight into the relationship between the values, but sometimes it's the easiest pattern. All of these patterns will be present if you have equivalent ratios, but you only need to find one to know your ratios are equivalent. Similarly, if any of these patterns does not work, then the ratios are not equivalent. Let's look at some examples. In our first example, we're comparing two ratios of old baskets to new baskets. If we look across the ratios at the old baskets, we can see that the top value is twice the bottom value, because 9 times 2 equals 18. If that is also true for the new baskets, then our ratios are equivalent. In this case, it is. 7 times 2 is 14, so the ratios are equivalent. Let's look at another example. In example 2, we're comparing ratios of friends to family members. If we look within the ratios, we see a 6-to-6 or 1-to-1 relationship in the second ratio. In other words, 6 times 1 equals 6. Well, that is not true for the first ratio, because 16 times 1 is not 18. Therefore, these ratios are not equivalent. We could have compared across the ratios. For the family members, we see that 6 times 3 will get me to 18, but that is not true for the friends. 6 times 3 is not 16. So either way, we see these ratios are not equivalent. Example 3. In this example, we're comparing orchids to lilies. This time we see a pattern within each ratio. Let's look at that first ratio by itself. We can multiply the number of orchids by 2 to get the number of lilies, because 10 times 2 equals 20. This pattern is also true for the second ratio. 22 times 2 equals 44. Since both ratios have the same pattern, these ratios are equivalent. Let's look at example 4. This time we're comparing friends to strangers. The relationship is a little harder to see. 10 is not a multiple of 6, but neither is 9. If we look closer across the ratios, we see that we can multiply by 1 and 5/10 to get from 10 to 15. 6 times 1 and 5/10 is 9, so these ratios are equivalent. However, since we had to multiply by a decimal, this is an example where cross products might have been easier. Let's rewrite our ratios as fractions. 6/10 equals 9/15. If the cross products are equal, then our fractions are equivalent. 6 times 15 equals 90, and 10 times 9 also equals 90. Since the cross products are equal, we've proven again that these ratios are equivalent. Let's look at one last example. Once again, the relationship is hard to find, so let's use our cross products. If I rewrite these ratios as fractions, I get 4/6 and 7/10. I can multiply across the diagonals to see if these fractions are equivalent. In other words, is 4 times 10 equal to 6 times 7? 4 times 10 is 40, and 6 times 7 is 42. Wow, that's very close, but they are not equal. So these ratios are not equivalent. Those cross products can be really helpful. That pattern will work every single time, so whenever you're stuck, you can always use cross products to figure out if the ratios are equivalent. And there you have it. Determining an equivalent ratio is as simple as finding a pattern between the ratios. Keep at it.